Today we're going to deal with section 4.3, which are the graphs of tangent and cotangent functions. We only have one more section after this on graphing, and that will deal with secant and cosecant. And then we'll be finished with the graphing chapter. We won't cut the unit there. We will do 2 sections out of chapter 5 before we take our next unit test. So that will be after spring break. Okay? I don't think you'll need to write this down. I just want to review with you really quick what vertical asymptotes are. Remember that vertical asymptotes are places where the denominator equals what? 0, but the numerator does not. Okay? A vertical asymptote is a vertical line that the graph approaches but does not intersect. As the x values of the graph get closer and closer to the line, the function values, the y values, either increase or decrease without bound. The reason we bring it up is that other than sine and cosine, which are waves, all 4 of the other trig functions have infinitely many vertical asymptotes. So that makes these not harder necessarily, but it gives you more that you have to memorize. So just kind of be on the lookout and make sure that you memorize what I ask you to memorize. Okay, so here's what we need to know about tangent and cotangent in order to graph them. Straight out of the gate, they do not have amplitude. They don't have amplitude because they're not waves. Only waves have amplitude. What they do have are vertical asymptotes, and they have a period, but their period formula is different. So let's kind of talk through it. If we take the form y equals a tan bx or y equals a cotangent bx, here's what a tells you. It doesn't tell you the amplitude. It tells you whether the graph is increasing or decreasing, and we'll talk about that on the parent function slides. But just remember they do not have amplitude. All right, little b still tells you the period, but instead of the period being 2 pi over little b, for tangent and cotangent, the period is just 1 pi over little b. So be really careful with that. 1 pi over b. And finally, the graph has infinitely many vertical asymptotes at the edges of each period. So the periods will be separated by vertical asymptotes. So I'll pause for a minute, kind of let you look at it and see if you have any questions. Okay, so let's go a little more into detail about how to graph y equals a tangent of bx and y equals a cotangent of bx. First thing you do is determine the period. Remember, you do that by taking pi over b. All right, so that's usually pretty easy. The hardest part is remembering how to find the asymptotes. Now, it has infinitely many, but your job is just to find 2 adjacent asymptotes, typically the ones that are around the center. So we usually find them close to 0. The formulas to find that for tangent are whatever your b is times your x. So you take your bx and you set it equal to negative pi over 2 and positive pi over 2, and you solve it for x, and those will be your vertical asymptotes. I really prefer this formula if you would like to change it to this. The vertical asymptotes equal negative pi over 2b and positive pi over 2b. It has been my experience that if people memorize it that way, they do better. It's up to you though. Your book teaches you here. I've just already solved it for b. Now for cotangent, we're going to use vertical asymptote formulas bx equals 0 and bx equals pi. If you want to memorize it another way, just memorize x equals, what's 0 divided by b? 0. And x equals pi over b. So you can see things are starting to kind of get confusing between all the pi's and 2 pi's and b's and 2 b's and all of that. So you really do have to do a good job of memorizing those or you're going to mess them up. Can we agree in here to do what I highlighted here in purple instead of the originals? Because that way they'll already be solved for you. Okay, after that we'll build a table of 5 values starting and ending with those vertical asymptotes. Unfortunately, or I should say fortunately, I don't know, cotangent still starts with 0, just like sine and cosine, but unfortunately, tangent doesn't. tangent is the only one whose table will not start at 0. So you may want to make a note of that. The tangent table does not start at 0. So that's kind of unfortunate. Makes the table, a little weird for most people. But just remember, it's the only one that won't start at 0. You should be able to, it should help you keep your asymptotes straight as well. All right, then we sketch the asymptotes as dotted lines, and then we put the other 3 points on there, and we will join the points with a smooth curve approaching those asymptotes. So here's what they'll kind of look like. If these are my asymptotes, tangent and cotangent, depending on whether their A values are positive or negative, will either look like this. They look a lot like a cubic function. Or they will look like this. There'll be a dot like here, here, and here. And they will look like a negative cubic function. And that just depends on what your A value is. Any questions about just kind of the basics there and what they're going to look like? No? Okay, well let's take a look at y equals tangent of x. That's our parent function for tangent. Y equals tangent of x. Okay, what's little a?
1.
Little a is 1. What's little b?
1.
Also 1. Does this graph have amplitude?
No.
But it does have a period. All 6 of the trig function graphs have period. And it does have asymptotes. So the next thing we're going to do is find our period. And the period of tangent and cotangent is
Pi over b.
pi over b, which in this case is pi over,
1.
which is just pi, not 2 pi. Not 2 pi over b, 1 pi over b. Then we're going to find 2 vertical asymptotes that are adjacent and close to 0. And the formulas we use for that for tangent are x equals negative, y'all remember?
Pi over 2b.
Pi over 2b, and positive pi over 2b. So once you find one, you also know the other. So in this case, the vertical asymptotes are x equals negative pi over 2, because it's 2 times 1, and positive pi over 2. So that's kind of your grunt work. You have to do that before you can get started. Once you do that, you identify the period and you find 2 adjacent vertical asymptotes, you can go and start making your table of values. So your table of values in this case will not start at 0. It's the only one. It will start at your smaller of the vertical asymptotes you just found. So it will start at negative pi over 2. You will skip 3 spaces, just like before. 1. And the final one will be your second vertical asymptote. Now the good thing about tangent is even though it doesn't start at 0, what's in the middle here?
0.
And that will always be 0. So that's nice because it makes these 2 will also always be the same, but one positive, one negative. So it does, it has its perks. What's halfway between 0 and pi over 2? So that makes this negative pi over 4 and this positive pi over 4. Okay? And there is a pattern for the y values as well, and we will learn it after we've done a couple. I'll insert a slide and we'll write it all out, okay? All right. Then what we do is we substitute, and I don't do well with negatives, but I'm going to try to talk you through them. I just learned the pattern. But if I imagine plugging into the formula tangent of x, what is the tangent of negative pi over 2? Well, if we go to our unit circle and we think about that, negative pi over 2 is this point here, right? So that's the point 0, negative 1. And what's the tangent there? Think really hard. Tangent is y over x. What is it? It's negative 1 over 0. And that's called, it better be undefined. It's a vertical asymptote. That's why they're vertical asymptotes. So this one and this one should always be undefined because they're your vertical asymptotes. So that's really nice. Undefined.
It'll always be undefined on top of that.
If it's not, you found the asymptotes wrong. So that's a good way to check. Yes, but for tangent and cotangent, it should always be undefined, the first and last point. Positive pi over 2, for this point right here, the tangent of it is positive 1 over 0, which is also undefined. Right? Let's go do the middle one. Because I'm going to get all my quadrantals out of the way. What's the tangent of 0?
0.
Y over x is 0 over 1, which is 0. Another thing that's always true, the middle point is always 0, unless you have shifted it vertically, and we have not done that yet. How about the tangent of negative pi over 4? Negative pi over 4 is negative 45 degrees, and what's a tangent of any 45-degree reference angle? 1 or negative 1, right? So right here, that's going to be negative 1 there. That's square root of 2 over 2, negative square root of 2 over 2 with a tangent of negative 1. So this guy is negative 1. And then positive pi over 4 will have a tangent of positive 1, yeah. And there's your table. They're really not bad, and they have a really nice pattern that I'll teach you, so don't worry too much about it. Once we get through tangent and cotangent, I'll teach you the pattern. Any questions right there? All right, let's graph it. If I graph it, it's not going to be very big, but that's okay. I'll put negative pi over 2. Aw, man, I can't do that. What do I need in between? What's my scale? Pi over 4, yeah. So I'm going to have to do negative pi over 4. Negative pi over 2. Positive pi over 4. And positive pi over 2. At the ends, you'll put your vertical asymptotes. And then we'll go through and we'll put our dots on. Our dots are negative pi over 4, negative 1. Zero, 0. And positive pi over 4, positive 1. Then we connect them in a shape that looks a lot like a cubic function. That's what one period of tangent looks like. It's okay, yeah, it's not too bad. So if you want to repeat it, here's what you do. You keep counting until you get 3 more slots in between. So like you take it and you measure it off and you say, okay, about the same distance between here and here. You mark over here and you insert another vertical asymptote. And then you divide it into segments. The center, here, and here. And you can keep counting by 1/4. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. You would count by your scale if you wanted to name those. So what is this? 3/4? Pi. 5/4, right? Okay. And then what you do is you just recopy those points into the same relative positions. So the middle one will still be at 0, this one will still be at a negative, and this one will still be at a positive. And we could do that over and over and over again. That was weird. Over and over and over again. That's what tangent does. It repeats that shape over and over and over again. We could do it off again over here in the negatives if we had enough room. That is 2 periods of tangent. We'll pause right there. Okay, so now let's look at the cotangent function, y equals cotangent of x. Once again, a is 1, b is 1. Now, a is not going to affect amplitude because we don't have it, but it will tell you what your table values are going to be. So these will be 1s and negative 1s, and 0s, obviously. Then we're going to find the period. Period is pi over b, which in this case is just pi. That's the standard period of tangent if b is 1. Cotangent as well. Then we're going to find the vertical asymptotes. We find those with the formulas. This is where people usually forget. X equals 0 and x equals pi over b. So 0 and your period is the way that'll always end up. So what is pi over b?
Pi.
All right, so my table is going to start and stop at 0 and pi. Those are going to be my vertical asymptotes. Any questions about that? And that's just a formula you have to memorize. X equals 0, x equals pi over b. That's for cotangent. Then we'll build our table. X, y, 0, skip 3 spaces, ending at pi over b. Is that good? Okay. What's halfway between 0 and pi?
Pi over 2.
And this one would be,
Pi over
Pi
2.
over 4.
and so that'd be 1/4, 2/4, 3/4. Good. And then the start and stop better be undefined. If you're not sure, look at your unit circle and make sure cotangent is x over y on your unit circle. So if we look at 0, that's 1, 0. And sure enough, 1 over 0 is undefined. The middle one should be 0 always. If you look at pi over 2, that is 0, 1. X over y is 0. This one and this one will either be a or negative a. And those are the ones you have to be careful because those are the ones people mess up. You should be able to look at this one and tell that's in quadrant 1. So the tangent of pi over 4 is positive 1. This one is in quadrant 2. So tangent is negative there. So it's not really hard, to fill out these tables. Any questions about filling out the tables for tangent or cotangent? No? Okay. Then we just build a graph, and we'll do 2 periods of this. We'll put a 1 and negative 1. We will put our vertical asymptotes at 0 and pi. So I'll let this be pi. We'll insert some vertical asymptotes. It's kind of hard to see when you go over the top there of the y-axis. That's the point, that's the line x equals 0, right? And this is the line x equals pi. And then we'll put halfway between. It's pi over 2. And I'm not going to put them on because I'm kind of low on space, but that's pi over 4 and 3 pi over 4. Then all you have to do is put your dots on. Unless it's been shifted, the center dot should be at 0. And this is a little different. Look, this one is high here and low here. So it looks different. It's actually like a tangent graph that's been moved over to the right and flipped across, spun around the center line there. Make sense? Okay, that's one period of cotangent. If you want to make another, you can either go out here to 2 pi, or you can go backwards and make one over there. Which way do you guys want to go?
Right.
I'm going to go right and do a 1 on the positive this time. Okay, so I go to the right. I have to go another whole period, so another pi, so over here, and that would be 2 pi. And we'll put our asymptote. There will be another asymptote there. We'll go in by halves. So that's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4 would be 3 pi over 2. 7/4, 8/4. And then we just copy our dots on into the same relative positions for the first, second, and third points in there. And make a second period of cotangent. So here's something you kind of need to know. Cotangent, if A is positive, cotangent decreases. What does it mean to decrease?
Get lower.
It means, it starts high and drops low as you go from left to right. And I don't usually make my students memorize that, but your book makes a pretty big deal out of that. If we back up in a second and we look at tangent, do you remember whether it increased or decreased? It increased, yeah. Let's back up and look at that. Now that's only true if A is positive. That's why I don't see the point in memorizing it, because you'll get it backwards. If A is negative, cotangent will increase and tangent will decrease. So it really, memorizing that isn't going to help. There are other things that will help you figure that out better just by thinking about it and looking at the table. But let's definitely back up and mark that. We can see that these are going from low to high, so those are increasing. So if A is positive, tangent increases. I think there's a slide or two about that. Your book kind of makes a big deal out of that. I don't. So those are your parent functions. take a look at this graph right here and imagine it continuing forever. Would it have y-axis symmetry or origin symmetry? Can I fold it right along the y-axis and they match up? No. So it has origin symmetry. All 6 of the graphs have some kind of symmetry. Sine has origin symmetry. Cosine has y-axis symmetry. Tangent and sine match up a lot because tangent is sine on top, sine over cosine, so they match up a lot. And then cosine and cotangent match up a lot. This guy, if you imagine copying another, he will end up having, my brain won't talk. What kind of symmetry is that? Y-axis symmetry, right? Is that true?
Yeah.
No, that's still origin. Isn't that origin? That's origin symmetry. Look at it. If you imagine here, think about it. Imagine another, here, I'll draw it for you. Imagine another one over here. It's not very pretty. Is that going to match up perfectly if I fold it along the y-axis, or would I have to fold it 4 times to get it to match up? That one also has origin symmetry. And you don't have to have those memorized. You can usually just look at them. So I'm not big on making you memorize all that stuff. But, you know, those are the sorts of things you need to be able to piece together, you know, and connect the algebra to the trig and the graphs to the trig functions. So if you do look at a graph, I would like for you to be able to tell if it has origin or y-axis symmetry. Okay, let's break there.